Hi everyone, welcome back to my channel. So in this video we're gonna learn about electronic affinity, which is also called electron gain enthalpy. So we can define electronic affinity as the amount of energy released when an electron is added to neutral isolated gaseous atom of an element. So we can write the definition as the amount of energy released when an electron is added to neutral gaseous atom of an element. Is called electron gain enthalpy. And we can write the expression for electronic affinity as X is the gaseous isolated atom for which an electron is added, and it forms an anion because the electron is added. And another important point to note is electron gain enthalpy is always an exothermic process because it always releases energy when an electron is added. And electron gain enthalpy is always negative for first electron gain enthalpy, like E1 is always negative because the energy is released. But there are some exemptional cases for which first electron gain enthalpy is positive, and those exemptions are Be, Mg, and nitrogen and all noble gases. These have positive electron gain enthalpy. And always remember that the second gain enthalpy is always positive because in the first gain enthalpy we added one electron, and if we want to add one electron again, there will be some repulsions between electron and electron. So to overcome that repulsions, we will add some amount of energy so that it will become positive. So we can say that second gain enthalpy is always positive. This is the key point. And the next topic is the factors affecting electronic affinity. The first factor is nuclear charge, atomic size, shielding effect, and electronic configuration. And as I told you that noble gases have stable configuration, so they have their electronic affinity values as positive. Noble gases have positive electronic affinity, and for nitrogen and phosphorus they have half-filled electronic configuration, so their electronic affinity is close to 0. the next one is variations of electronic affinity across groups and periods. And as we move down the group, the electronic affinity decreases due to increase in atomic size. If the atomic size increases, it will be easy to add an electron. So the electronic affinity decreases. We can write like, as we move down the group, first electronic affinity decreases due to increase in atomic size. And electronic affinity increases across the period due to increase in nuclear charge and decrease in atomic size. First, electronic affinity increases across the period due to increase in nuclear charge and decrease in atomic size. So we can say that electronic affinity is directly proportional to nuclear charge, and electronic affinity is inversely proportional to atomic size. Now we'll learn some exemptions for electronic affinity. So we know that the electronic affinity decreases down the group. But there are some exemptions. Like, first exemption is chlorine has more electronic affinity than fluorine, which is 7th group. Second one is sulfur has greater electronic affinity than oxygen. This is of 6th group. And third one is phosphorus has greater IP than nitrogen. Greater electronic affinity than nitrogen, which is of 5th group. And silicon has greater IP than carbon, which is of 4th group. And these all are p block elements. And these all have, that is, the third period elements have greater electronic affinity than second period elements, which are of p block only. And in the whole periodic table, chlorine has the maximum electronic affinity. In whole periodic table. The order of electronic affinity among the halogens is: chlorine has greater electronic affinity than fluorine, greater than bromine, greater than iodine. This is for halogens. That is 7th group. And the order for 6th group elements is: sulfur has greater electronic affinity than selenium, than tellurium, than oxygen. This is for chalcogens. 6th group elements. So in this video we have learned about the definition of electronic affinity. factors affecting electronic affinity, variations of first electronic affinity in groups and periods, and some exemptional cases. Thanks for watching this video. Please do like, share, comment and subscribe to my channel, and please do click on that notification bell icon to get updates of my new videos.